Assalamualaikum and hi. We are from Engineering Faculty, which is CEEC 1101A from Group 4. We will present about application of differentiation, which is maximum and minimum problem. Before that, let me introduce my group members first. My name is Muhammad Nur Hilman bin Daud. The second one, Nur Zafan bin Nur Zakiman. The next one, Nur Zalika binti Hassan, and last but not least, Alaya Maisarah binti Amran.
Assalamualaikum, my name is Nur Zalika and I will introduce you to derivative. Derivatives are also known as differentiation, represent a rate of change. Differentiation is the process of determining a derivative. In single variable calculus, the two basic operations are differentiation and integration. Derivative can be used to find first rate of change in volume. The second one is finding maximum and minimum value, and the last one is find profit and loss in business. According to Wikipedia, the use of infinitesimal to study rate of change can be found in Indian mathematics as early as 500 AD, when the astronomer and mathematician Aryabhata used infinitesimal to study the orbit of the moon. The use of infinitesimal to compute rate of change was developed by Bhaskara too. Derivative is widely used in other courses as well, such as science, physics, and engineering. In our project, we use derivative to find dimension that will minimize the value.
Assalamualaikum and hi, I'm Hilman. So I'm going to share with you about the problem statement. Here is the question for our group assignment. A showroom for a department store is to be rectangular with three-sided of fence which built next to a straight wall. The showroom is to have 800 feet square of floor space. What dimension will minimize the length of fence used? Before we make a calculation for our question, I will show you step by step on how to answer this question. Next, we move to methodology. For the first step, we should draw an appropriate diagram and label appropriate quantities. The second step, we need to equate an appropriate formula to the given value. We write y as a subject, naming it as equation 1. Next, we write another relevant formula and naming it as an equation 2. We substitute equation 1 into equation 2. Next, we move to another step. For the step number 4, we need to find dl over dx. When dl over dx equal to 0, we find the value of x. Then, we need to find d square l over dx square. For the final step, we replace the x value in the second derivative. Here is the step-by-step, or we call a methodology, before we answer the question.
Hello, my name is Nur Zafan and I will be explaining the result and solution. In this part, I'm going to show you how to calculate the dimension that will minimize the length of fence used by following the methodology that has been mentioned previously. Okay, so let's go. The first step, which is step A, is to draw an appropriate diagram and label appropriate quantities. For this problem, the diagram is a rectangular shape and the sides for fences are labeled as X and Y. For the next step, which is step B, we are going to equate a formula to a given value. Okay, so from the question, the given area of the showroom is 800 feet square. So, we can write an equation for the area, which is X times Y equals to 800 feet square. Then, we will write y as the subject by bringing x to the right side and label it as equation 1. For step C, we need to write another relevant formula. So in this case, we can write a formula for length of fence, which is 2x plus y. Then we can name it as equation 2. Moving on to step D, we have to substitute equation 1 into equation 2. We can replace y in equation 2 with 800 over x from equation 1. Then we will get length of fence equals to 2x plus 800x to the power of minus 1. Okay, for step E, we are going to find dl over dx. By differentiating, L equals to 2x plus 800x to the power of minus 1 using power rule. Then we will get 2 minus 800x to the power of minus 2. Next step is step F, which is to find the value of x when dl over dx equals to 0. We need to write it as 2 minus 800x to the power of minus 2 equals to 0. Then put x in the denominator of 800. Next, continue the calculation and we will achieve the value of x, which is 20 feet. Moving on to step G, from dl over dx, we need to use second derivative test. We will get d square L over dx squared equals to 1600 over x cubed. For step H, we must replace the value of x in the equation of second derivative test from the previous step. Okay, so we will get a positive value that indicates a graph for minimum value, or in this case, minimum length of fence used. On the same step, find the value of y by replacing the value of x, which is 20 feet, into equation 1. Then we will get y that is equal to 40 feet. Lastly, we will achieve the dimension that will minimize the length of fence used, which is 20 feet times 40 feet. Now, we have achieved our answer. So, without further ado, I will pass it on to the next person.
Hi, my name is Adam and Sarah. So let's move on to the next one, which is conclusion. Derivative is defined as the rate of change of one quantity with respect to another. Derivative has been found as early as 500 AD. It has a lot of function whether in real life or in calculus. The concept of derivative is used in many ways, like rate of change of temperature or rate of change of shapes and sizes of an object. Derivative is also used to determine the change of rate, while in our project, derivatives are used to determine the minimum value of the length used. Last but not least is reference. These are the links of website that we use to find some information to complete this project.